Okay, my dear, let's solve some steps to solving an equation. If you have these steps, you'll be able to solve any equation, okay? So I'm going to give you the steps for solving any complex equation, and you'll probably start off with simple ones, but this will help you tremendously. The first thing you want to do is do any distributions. That means using the distributive property. For example, 4 times 3x minus 2 equals 8x minus 3. You want to multiply the 4 with the 3x and the 2 first, okay? And that gets rid of the parentheses. Then, if you have any fractions in your equation, you want to get rid of them by multiplying each term in the equation by the common denominator. Let me give you an example. Suppose you have the equation 3/4 x plus 2 is equal to 2x minus 1/2. Well, what you want to do here is the common denominator between the 4 and the 2 is 4. So you want to multiply every term by 4 over 1. So this is what we do. And then when you do this for the first term, the 4's cancel out and you just get 3x. And then you multiply your 4 times 2 and you get 8 equals, then you multiply your 4 times 2x and you get 8x, and then you multiply your 4 times negative 1/2, so that's 4 over 1 times 1 over 2, and that gives you 2. So that gets rid of the fractions, so you don't have to worry about any fractions. Now it's an easier equation to work with, okay? Now just note, this equation is not continuing down here. This is just a different example. Okay, now the next step that you would think to do is combine any like terms on the left side and simplify. And then combine any like terms on the right side and simplify. For example, if I have 12x minus 8 plus 5x equals 8x plus 4 minus 2. Well, I can take the 12x and the 5x on this side of the left side and just combine them. I get 17x. Then on the right side, I can take the 4 and the negative 2 and combine them and get positive 2. And then it's a simpler equation, then I can move on. All right, we're always trying to make it simpler. What's the best way to make it simpler? Okay. Now, the last one, one of the next things that you want to do is you need to get the letters on one side and the numbers on the other side. Now, I give you a little hint. It's always best to move the smaller values of the variable first. 99% of the time, that's a good idea, okay? So when I have 4x plus 7 equals 8x minus 3, I want to move this 4x to the other side. So I'm going to subtract 4x, and then I'm going to get 7 equals 4x minus 3. And then after I do that, then I see that I have to bring this minus 3, add 3 to get it to the other side. So I'm going to add 3 to both sides, so I get 10 equals 4x. So now I'm near the last step. And you're going to multiply or divide to get the final answer that you're looking for. And because I have 10 equals 4x, I'm going to divide by 4 on both sides and get 5/2 equals x, and then I'm done. Okay, so those are the steps to solving an equation. Now in your book, let's take a look real quick at some of the examples that are in the book. These are simple examples that they start off with. So in our step, we're just doing the last step here like we did over here where you had to, well, you don't even have to divide or multiply in this example. In this example, all we have to do is add 5 to both sides and we're done. In this example down here, what they're asking us to do is, oh, okay, well, here's our variable. We don't have any distributions. We just have 2 negatives in a row, so we have to add 4. That makes it a positive 4. And then you're going to just subtract 4 to get your answer. So there's not a lot of steps here. There's no distributions, no fractions, no combining like terms, but simplifying the minus, okay? And that's all you did there. All right. So now in another example that you have, let's take a look at some of these in here. All right. Now, These are the ones that you want to pay attention to with a couple of your steps, okay, because there are some fractions in these, all right? Now, in all of these, there's only one term that's a variable, okay? So these are the simpler ones to start off with. But let's take a look at these fractions here, okay? Now, in this one where you have 2/5 equals a minus 1/5, I know what we did. Let me zoom in so that we can see this a little bit, okay? So 2/5 equals a minus 1/5. Because we can multiply everything by 5, just get rid of the fractions, okay? So let me show you how that works. So 5/1 times 2/5 equals 5 times a minus 1/5 times 5/1, right? Well, those cancel out. You get 2 equals 5a, and these cancel out, and you get minus 1, all right? That's exactly what you do. So then you add 1 to both sides, so you're going to get 3 equals 5a, and then you just divide by 5, and 3/5, you just divide by 5 on both sides, and then 3/5 equals a. So it helps you to not have to deal with the fractions. If you get rid of the denominators, then you don't have to worry about the fractions. But if you want to deal with the fractions, then you just deal with the fractions, and you don't have to do that step. But that's up to you to do, okay? Now, for this one where it says r plus 3 1/4, now we can do a couple of things here, all right? We can say, let's make this an improper fraction, okay? Or we can say, let's make this 2 1/2, 2 2/4. But what I want to do is I want to make it an improper fraction. 4 times 3 is 12 plus 1 is 13. So I'm going to do 13/4 equals 2 times 2 is 4 plus 1 is 5 equals 5/4. Okay. Now I'm going to get rid of my fractions. I'm going to multiply everything by 4. So all of this is going to be multiplied by 4. So I'm going to multiply every term by 4/1. Okay? So I'm going to get 4r plus 4/1 times 13/4. The 4's cancel out, so I get 4r plus 13 equals, and then I'm going to do 5/4 times 4/1. Well, the 4's cancel out, and I just get 5. So it's a lot easier to work with now. So all I'm going to do is subtract 13, because I got to get my numbers on the other side. Okay, so I'm going to get 4r equals 5 minus 13, that's going to give me a -8, right? And then I just have to divide by 4, and I get r equals -2. Okay, so that's the way that I would do that one. I just don't like to work with fractions because students, we get too mixed up with fractions. So let's get rid of them and we're good to go. So that's how I would do that one. And then for examples like number 33 and 34, okay, let's take a look at those. 35, those three right there. Here, for number 33, you really just have to make this a positive y, okay? So you're going to have 19 plus y equals 25, and then because your y is here, you just have to subtract 19, no problem. Now this one, we're just going to clean up the left side, okay? We're going to combine any like terms and simplify. Well, we can't combine any like terms, but we can simplify. So we're going to get the absolute value of 2, which is just 2. And these two negatives make it a plus b is equal to 6. Of course, they use a b with a 6, so we can't figure out which one is which, but that's crazy. And then you can just subtract 2. Now here, for number 35, you just have to combine your like terms, which is your numbers, okay? So positive 4 and a negative 3 is 1. So you really have x plus 1 on this side equals, and then we're just going to do the 6 times 5, which is 30. Then we have a nice, easy equation to solve, okay? I hate to use the word easy, but simpler equation to solve, right? Okay. All right, so that takes care of those, and basically the same thing for the others, all right? Now, then they talk about, let's do some multiplying and dividing, okay? In the steps that I showed you this would be the last step where I said to multiply or divide to get your final answer, because that's all they're giving you in this example. They give you negative 4x equals 1. Sorry about that. They give you negative 4x equals 1. Okay, so all you have to do is divide by negative 4, and you get your answer, and it just happens to be a fraction. Right? So all the other steps above we don't have to do. All right? Okay, so let's take a look at some more examples there. Here's another one where you have to multiply to get your answer, because there's nothing else to do except for that one step here. So you have to multiply by 5 over 1, multiply by 5 over 1 to solve for x. Your x's cancel out, your 5's cancel out, and then you get your answer. Okay? Now down here in this example, you just have a fraction in front of your variable, so you're going to multiply by the reciprocal, okay? Or, let me show you another way you can do this. We don't even have to multiply by the reciprocal, okay? Watch what I do. So I have 10 is equal to negative 2/3 times m. Well, my denominator is 3, so I'm going to get rid of my denominator first. Oops, let it zoom in. I'm going to get rid of my denominator first, okay? So, when I get rid of my denominator first, I'm going to multiply every term by 3 over 1. So I'm going to multiply this by 3 and this by 3 over 1 because it's a fraction. Okay, so 3 times 10 is 30 equals, this 3 cancels with that 3, and I get negative 2m. Now, all I have to do is divide by negative 2. I divide by negative 2, I divide by negative 2, and I get negative 15 is equal to m. So I get the same answer, but I didn't have to worry about the fraction here. I just multiplied by my common denominator, which was 3. The only denominator I had was 3. So it's easier for me to do that, okay? All right, so if you want to do them that way instead, it's much better. That's up to you. So let's take a look at some more examples that they have. Let's take a look at this example, example number 5, okay? They talk about a geometry connection. Well, this is very important to talk about because your teacher is going to make sure you have to understand this, because they're talking about similar triangles. All right, so let's talk about similar triangles. Let's go to this one first. Right down at the bottom here. Now see, there's a bunch of dots here. Now this is a totally different example. And this example is very important for you to understand. And hopefully your teacher will show that. But let me show that to you now. When you have similar triangles, that means you have the same shape but a larger size for one of them. One of them smaller, one of them is bigger. Now, the sides have to be in the same ratio. They have to have the same fraction. So this side, little a, this side, little b. Okay, so this ratio, this fraction, then when you make the length of this side to the length of that side, the length of AB to the length of DE, these two have to equal the length of AC over the length of DF. And then that also has to equal the length of CB over the length of FE. Okay, so the fractions that you make with the corresponding sides, AB is the length that corresponds with DE on this side, AC is the length that corresponds with DF on this side, and CB is the length that corresponds with FE on this side. When you make those fractions, they all have to come down to the same fraction. Okay, so in the next example, let's take a look at this. All right, well, what they do here in this example is they show you that you have two similar triangles. One is bigger than the other. Now, you can tell that angles C and F are the same. All the similar triangles have the same angles, but their sides are different, okay? But side CB and side FE are the same corresponding sides. So you're going to take the length of CB over FE. Okay? The length of CB over FE is 10 over 5. So we have to find x. So we're going to create a proportion, and this is how they create their proportion. So what they did, I usually like to put my 10 over 5 first, but that's okay. They didn't do that here. They put the x over 7 first. So the side that corresponds with x is 7. So they write x over 7 equals 10 over 5. So x over 7 equals 10 over 5. That's how they create their ratios, and we call this a proportion. When we put two fractions equaling each other, that's really a proportion, okay? But anyway, so that's how we solve it. So now we're going to, so how do we get rid of this? Now, they multiply by 7, I don't know what, okay, so to solve for x, here is your x, okay? So you're saying x divided by 7, so now you're just going to multiply both sides by 7 to get your answer, okay? And that's exactly what you want to do. Now, you can do that, or we can do this. When we have x over 7 equals 10 over 5, right? First of all, I would reduce the 10 over 5 because that's 2, isn't it? That's just 2. 2 over 1. So this is x over 7 is equal to 2 over 1, or just 2. Okay? And then I say x over 7 is equal to 2. And then I just multiply both sides by 7. I multiply by 7 over 1, multiply by 7. I get x equals 14. X equals 14. Okay? Now, if you didn't simplify the 10 over 5, or we can do it this way. X over 7 is equal to 10 over 5. Now I'm going to cross multiply. We can only do this when we have two fractions. Okay? 5x is equal to 7 times 10, which is 70. And then you divide by 5, you divide by 5, you get x equals, we're going to take 70, divide it by 5 on the side, 5, 6, 7, 20, we get 14. So we still get our answer, okay? So that's different ways of doing it. So, again, what they did was they just multiplied both sides by 7. You still get 70 over 5, and you still have to divide. You get x equals 14. Or you can take x over 7 equals 10 over 5, and I can reduce that first, and then I just multiply both sides by 7, and I get 14. That looks a little bit easier. Or, if you didn't see that you could reduce, you can cross-multiply when you have fractions, okay? So that kind of gets rid of your denominators quickly, but you can only do that when you have a fraction equaling a fraction, okay? So, 5 times x equals 7 times 10. 5x equals 70. Divide by 5, you get your answer. Okay, so that's how they did that. But that's how they're using similar polygons. So you have to pay attention to knowing how to use similar polygons. Okay, so let's take a look at number 13 at the bottom so that you can see what you have to do for number 13 at the bottom. All right, so here we have two triangles. They're similar. They tell you they're similar. So now we have to set up our little proportion to solve them. Okay, so let's do that. Let's set up our little proportion to solve them. It's set up to show you that this side and this side, the x and the 3, are corresponding, and the 4, the two bottom sides, are corresponding. So you write your equation, x over 3 is equal to 4 over 6. That's all you do. Smaller triangle on top, larger triangle on the bottom. Smaller triangle on top, larger triangle on the bottom. Okay? And now we're going to cross multiply. All right? I'm not even going to reduce. We're just going to cross multiply. Well, you know, it's easier to reduce. Let's reduce. X over 3 is equal to 2 over 3. Because that's 4 over 6, which is 2 over 3. So now we're going to cross multiply. Okay? We're going to cross multiply, cross multiply. So we're going to get 3x is equal to 3 times 2, which is 6. We divide by 3. We get x equals 2. Bingo. We're done. Okay? That's how you solve those. And I'm sure that will be one that's on the test. Okay? All right. Let's take a look at some of these problems in section 3.2. I think this is section 3.2. Yep, it is. Okay. So more problems in section 3.2. Let's take a look at these. again, the steps that I gave you, they don't have a whole lot of distributions. They don't have a whole lot of everything else. So their steps are just minor, okay? So what I'm going to do, I'm sorry, let me just pause this for a minute. So, taking a look at some of these equations, let's take a look at the more, okay, these right here. You're just going to multiply by the denominator on both sides, okay? Now here, you're going to do the same thing. You're just going to multiply by the denominator on both sides, okay? Just be careful here. I would multiply by -4 on both sides, because here's your variable, so you're multiplying by -4. Okay, here's your variable here, so you're multiplying by 5 on both sides. Okay. Same thing with these, you're multiplying by the denominator, and just be careful, you're multiplying here by -2, because there's your variable. All right? Okay. And then you can solve it because it's quicker that way. Now for these, let's take a look at how you solve these. All right? Again, let's just get rid of the denominators. Let's take a look at how we do these. They don't need to be difficult. All right? So there's a couple of things we can do. The easiest thing to do is just multiply by the 3 first. Get rid of the denominator, okay? So I'm going to multiply this side by 3 over 1. 3 over 1 times -2/3. I'm going to use x instead of t, equals -16 times 3. Actually, okay, let's do that. All right, let's get rid of the 3. Okay, now we have -2x equals -16 times 3. 6 times 3 is 18. 3 is -48. Okay, and then our next step is just to divide by -2. And so we get x equals a positive 24. Okay, very good. Now, that's how I would do that one. You can multiply by -3 over 2 at the same time, but it's up to you. But that's how I like to do them. So down here, you got 3/4 z equals -5.5. Now, again, I would make this an improper fraction. So let me show you how I would do that. So 3/4, I'm going to use x equals -10, -11/2, right? Okay. The common denominator is 4, so I'm going to multiply every term by 4 over 1. Multiply this one by 4, multiply that one by 4. So if I multiply this by 4 over 1, the 4's cancel, and I just have 3x equals -11 over 2 times 4 over 1. That becomes 1, that becomes 2, so I get 3x equals -22, right? And then when I divide by 3, it's much easier, and I get x equals -22 over 3, and then you just rewrite it as a mixed number. So let's take a look at the other one that I wanted to show you, like right here. 1/3 y equals 5 2/3. I want to make this an improper fraction first, okay? It's just easier. I think it helps. 5 times 3 is 15, so this is going to be 17 over 3. My denominator is 3, so I'm going to multiply everything by 3. 3 over 1, so multiply these all by 3 over 1. Okay, so I'm going to multiply that one by 3 over 1 and that one by 3 over 1. So I'm going to get y equals, and 17 over 3 times 3 over 1 equals 17. So it's a lot easier when you do them that way. I think it is anyway. So let's take a look at a couple others here. Down here we have to clean up a little bit. Okay, so there's a little bit of simplifying. Okay, that's one of the steps that was prior to the last steps that we had to do. Okay, so here you have to clean up this side. So be very careful here. This is a positive 8, and you still have that negative. So you end up with -8 on this side, even though there's an absolute value. So be very careful with that. So this says -1/2 b. I'm going to use x equals -8. Okay, I'm just going to multiply by my denominator. All right, I'm going to multiply everything by 2. I'm going to multiply this by 2 over 1. I'm going to multiply, so each term gets multiplied by 2 over 1. So this is going to be, the 2's cancel out. I get negative x equals, and negative 8 times 2 is negative 16, so negative x equals negative 16. And then I just divide by negative 1, right? So then I'm going to get x equals 16. All right, so we divide by negative 1, we divide by negative 1. And then we get x equals 16. And that's our last step. Okay, so that's how you're going to do those. So be very careful with those as well. So that's section 3.1 and 3.2. Okay, and we will stop here. Well, let's not just stop here because there are some more examples here with similar polygons. Okay, so how do we set up 58 and 59? Let's take a look at 58. Okay, they're set up so that you can see the corresponding sides, okay? So the bottom of the small triangle is corresponding to the bottom of the big triangle. So that's 6 over 10. So write that, 6 over 10. That's going to have to equal the side of the smaller triangle corresponds to the side of the larger triangle. So that's x over 5, okay? So 6 over 10 equals x over 5. Got it? Smaller, larger, smaller, larger. Okay, so you have to make sure you have the same size on the top and the same size triangle on the bottom. 6 over 10 can be reduced. I'm going to reduce it to 3 over 5 equals x over 5. All right? Okay? So 3 over 5 equals x over 5. So then I'm going to cross multiply. I can cross multiply, but I think you know what your x is going to equal. So 15 is equal to 5x. You divide by 5 and you get x equals 3. Okay? That one wasn't too bad. And then this one over here, what are you setting it up as? Again, smaller triangle. The bottom corresponds to the bottom of the larger. The side corresponds to the side of the larger. So small over large, small over large. Okay, so we're going to do x over 12 equals 4 over 8. Again, 4 over 8 can be reduced. I'm going to reduce that bad boy, okay? X over 12 is equal to 1 over 2. Makes it easier when we cross multiply, okay? So we're going to get 2x is equal to 12, and when we divide by 2, we get x equals 6. Bingo! That wasn't so bad, was it? Okay, very good. All right, so that's about it, folks. So that's section 3.1 and 3.2 examples, okay? And I will send another video for others. Talk to you later. Have a great day, and good jobby.